So, we, on our paper, even though it doesn't look terrific, should have drawn some axes. Right now, if I was you, I would look at the points before I start drawing and double check, like, okay, my widest point out is 5, 5. However, since we're getting into geometric transformations, and if you didn't do this, don't erase, but you might want to grab some like graph paper if you accidentally drew the axes on the edge. Guys, from this point forward, we're pretty much always going to be talking about a 4-quadrant graph. So you should be used to putting your axes in the middle of the graph. So like somewhere approximately middle of the graph. And then I like starting with like one color and then changing to a different color when I get told to do something else. So 2, 1, just to double check that we all know, like, and remember how to graph these things. That's our X and that's our Y. So we go 2 to the right, 1 up. There's 2, 1. 3, 1, 3 to the right, 1 up. 5, 5. And 2, 5. It's nice when points share values. Like, since these both share the X of 2, I know those are going to line up. Since these both share the Y of 5, I know those are going to line up. So now what I want you to do to each value in each of those points is multiply them by 1. Talk to your neighbor about what just happened. Maddie.
Yes, sir.
What happened?
They stay the same.
They stay the same?
Yes, they're so lonely.
Oh, because I guess when we multiply by 1, quote unquote, nothing happens,
I
they
know.
say.
They have such a lonely life.
Okay, so what if we multiply every value of every point up there by -1? Do that. Do it. You might have a hypothesis, but do it to double check. So essentially everything's becoming the opposite that it was. In your head, are you thinking that's going to reflect? If you're thinking it's going to reflect, are you thinking reflect across the x-axis, reflect across the y-axis? If you're not thinking it's going to reflect, what are you thinking it's going to do? This shape is unique enough, we should be able to tell what has happened. So I'm going to change colors, and that's why up on the start slide it told you to grab some colors. But I mean, if you guys ignore my suggestions, I'm smart enough now to not try to control 12-year-olds. I know that's a silly, pointless task.
So pick a color.
Blue, because I already did.
That's a good color.
Okay, thank you. -2, -1. Pretty sure I have Ingrid Michaelson stuck in my head, and I don't know why. I gotta make sure I keep this under 30 seconds. What happened here? Mick, you want to take a shot at what happened here? It rotated what? Well, but rotations have degree measures, right? Did it rotate 90? Did it rotate 180? So what we just saw happen was XY's you might write this down, became the opposite of what x was and the opposite of what y was. And that rotated us 180 degrees. Now, guys, I want to teach you a method that I did not know until I was a teacher. Sorry, Owen. When you're trying to check what rotation has happened or when you're told to rotate, like depending on if it's already happened and you're trying to figure out what it was, or if you're being told rotate from this point, this is called the hockey stick method. And guys, I want you to look up here. Like, stop drawing for a minute. Just look up at the screen. We're going to draw, and actually first I'm going to draw on top of the screen to show you guys, then I guess I'll actually do it on my paper. From the point of rotation to the point you're rotating from. Now, if we're on the ice, like playing hockey and somebody's hockey stick on the ice, and you put your foot on one side of it and kick the other side, it'll spin, right? If your foot is holding the one end. So I start spinning my hockey stick the positive direction, because we know counterclockwise is positive direction, 90 degrees would have stopped us here. So did we only go 90? No, because the shape would have been up here. This point would have been here. So we keep going, and now that's 180 degrees, because we know from here all the way around to here is a 180 degree rotation. Now, if you were told to go 270, right, 270 degrees would be 3/4 of a turn. That would actually then come down here. Yeah, green's a little easier to see. But you can draw your hockey stick from the center of rotation, right? So imagine standing on one edge, like one end of the hockey stick. If you've seen a hockey stick, it's got like a paddle on the end of it, right? So you stand on the stick part, kick the paddle part, and it rotates around to wherever we're supposed to go. Does that make sense? So what would then happen if instead of asking you to do -1, if I asked you to do -2, like multiply every single value of each of those points by -2. Talk to your neighbor about what would happen. You can go ahead and start doing it if you want. You might get mad at me for it, but... Ooh, we're restarting. Sorry, good question. Good question. Thank you for, keeping me honest. We're starting over with these points. So the negative rotates us down around here, right? But now we're going to do not just -1, but -2. So wait, 2, 1. So wait. So hold on. We're taking this shape, our original, multiply that by -2. So for example, this becomes -4, -2. So
That's a little questionable, sir. That's a tad wee little bit questionable. Oh, okay. We need to make a bigger graph.
We would need larger graph space, because what does multiplying by 2 do to the numbers? Alex? It doubles them. What's it going to do to the shape? Owen?
Enlarge it.
And more specifically, so it rotates it and it enlarges it by 2. So guys, what we're getting into now is dilations. Who's ever been to the eye doctor? Please at least lie to me and tell me that you have been, because if you haven't been, you need to go. It was middle school when I learned that I needed these, and honestly, I think I look well. You guys, you're thinking it, I'll say it. I look weird without my glasses. Now I want to get some new glasses. I think even nerdier than these.
You one's
But
bigger.
so, like, dilation, what's it mean when your eye doctor says, I'm going to dilate your pupils?
Make it
It makes them bigger or smaller, right? That's what dilation is. It changes the size. So what we're getting into now is called dilation of these geometric shapes. Cool. If you want to write it down, dilation is a change of size. So, so if Luis is dilating triangle ABC at the right, and he multiplied, hey, that should be an X. That chopped through with my hole punch. This should be an X coordinate, Y coordinate. You could maybe make a note right here. Describe how triangle ABC changed. If only we had like just talked about that during class. Maybe that's why if you do your homework the day it's assigned, it's fresh and it should feel not that difficult. I'm trying to give you a minute to write whatever you want on your paper. All right, so I know you'd be sad if we didn't use graph paper. So now let's shift to graph paper. We're going to try to draw this shape on graph paper and maybe leave yourself some space around it. And actually, guys, honestly, if you want to just make like a piece of graph paper that you might also use tomorrow or like, use multiple problems, you totally can do that. So what I mean is like if you just make one piece of graph paper with like axes in the middle, you could use this for multiple problems if you color code them. Color code. I don't know why I always want to say color code.
It's like you're putting them in color. Unless you put them in.
So like you could just like big piece of paper, XY axes.
Can we like redo?
Chapter 6. Graph stuff. All right, but we need to figure out where these points are if we're going to actually graph them. So I need someone to help me name these points so that we can actually graph them. And not like, Billy Joe. I mean, we need to name their X and Y.
Oh.
So where is this?
Never mind.
You can still help me out. Where is this?
You mean like?
It's XY coordinates. It's
Oh,
on your
yeah.
screen.
Oh, wait. It's 8-6.
Close.
6-8.
Close.
Negative 6-8.
Closer.
Negative 6-8.
No, you got it now.
Oh, see, I'm awesome. First try. Woo! Yes, it was. Just pretend. You have the imagination, Rick. Use it.
So we need to graph the point negative 6, 8 after Maddie had 3 tries.
It was
The
basically
point 6, negative 4. And yeah, negative 2. Negative 4. Oh, they're being nice to you. It's all even numbers.
Oh, that's sweet.
So on our graph paper, we're graphing negative 6, 8. Negative 2, negative 4. I'm trying to give you time to do this.
Thank you.
Then, again, multiply everything by negative 1. And I want you to see what happens and why. Multiply everything by negative 1.
I swear, if you keep shaking this hand. So should we draw the original?
Yeah, we definitely have to start with the original. Hey guys, it's nice to make checkpoints on your graph just to make your counting easier. I like to mark out where the 5s and 10s are. Like, word from the wise if you think I'm wise.
We all think you're wise, sir.
You don't want to be counting over and over and over again. You'd rather like jump to 5 and then go from there. So guys, like when I make a graph, I immediately make your life a little bit easier. I mark out the 5s and 10s. Because then it's easier to find -6, +8, because I can jump right to 5 and just go one more. Then I can jump right to 5 and go 3 more. If I was you, I would change colors from your first one to your second one. We're going to multiply by -1. Now, in the first problem we did, we rotated around the origin, and we ended up in a totally different quadrant. Are you sure those points are where they should be? Those are not the points I told you to graph.
I'm grabbing the original.
Bud, that's your homework. This is a different practice, like us in class. That's your homework. Compare with me. This is why you have partners. This one's going to be a bit more interesting when we multiply by -1. Okay, I guess more interesting is an opinion word.
Yeah, definitely. But that's okay. Use it. We respect it.
By the way, Finn got a tricycle for his birthday, and then I was that uncle that for my 3-year-old nephew, I bought him a bow and arrow. Grandma was not happy about that.
Wait, you want him a bow and arrow?
Not a real, it's like a
He's
Nerf.
gonna be the next Katniss
It's like a Nerf bow and arrow, but yeah, I got some judgment from the one grandma, and I was like, it's fine. I also bought him a car when he was like one of the little tykes like car things, but that was like at last
Wait, sir,
last
I don't-
birthday or something.
Sir, I don't understand. Like, that was the best gift we could have ever gotten him. Like, that's like hard.
It says ages 14 and up, and I was like, what 14-year-old's gonna play with this? When I was 14, I was shooting rifles and shotguns.
No,
Like,
for real.
I was in Boy Scouts, and I would just go to Scout. We're talking about I bought a bow and arrow for my nephew for his birthday, and I got in trouble.
No, and the thing is,
Well,
it's
no,
like,
so awesome.
I wish I had like one of those like little like electric cars. I'm telling you, I cried so much because
But the ones were like.
So,
yeah,
I know I distracted us, but now I'm gonna pull us back together.
I never
If I multiply by -1, well, what was negative becomes positive, but what was positive becomes negative. So now I'm at 6, -8. Right? My 2 negatives will actually become 2 positives. It's not 2, 4. I need you to be able to do that on your own. Sorry, like I'm in the middle of something, kind of teaching a class up here. Positive becomes negative, negative becomes positive. What happened? Whoa. Anyone else spot that these lines are like perfectly straight with each other if I used a ruler and like there's kind of like a parallelogram that I sort of made in here. What happened? How does the green shape compare? So this is -6. What did multiplying by -1 do? Mick? What do you mean? Like it didn't mirror flip it. 360 would be back where we started. You want to keep trying, or you want to move on? Ahmad, what do you see? What do you think happened here? We multiplied everything by -1.
Yeah.
What happened?
So,
looked around kind of.
No, I thought it was going to break into the chorus.
know.
That-
I was waiting
The chorus of that song says what? Yeah, you spin me right. Guys, it's another 180-degree rotation. Guys, look at your paper.
I love the one
What was top left became bottom right. What was your bottom is now up at the top. What was your bottom left, the -2, -4, is now your top right. This is another rotation of 180 degrees. Because why does this one look different than the first one we did? The first one took this shape and said swing way around here. This one just Aqua?
Because the shape is in all 4 quadrants at the same time.
We are already crossing all 4 quadrants. So we did move 2 quadrants. Every point moved 2 quadrants. But the shape itself, because it's sitting over top of the origin, just spins around. Now you could also rotate 180 degrees like from a point on the shape and just spin the shape around itself. But what we practiced first is rotating about the origin. And guys, I could draw that hockey stick to my original point, to my new point, and it'll show me that 180-degree rotation. If you did not grab 6, whatever the other paper is back there, grab it. Yeah, if you didn't grab 621, grab it. No, 622. I mean the other paper, guys. Like the other one that was back there. Yeah, 622. Sorry, I think somebody had set their calculator on it. All right, so again, graph paper, thank you, printer. But now on this one, at least it's every even number has the boulder lines. So now 622. It was the second paper that was back there. We're just going to start tomorrow's lesson now so we can try to squeeze in 6 this week.
Should I just put this away?
That's what we're doing. Like, that is what we're doing right now. Oh, that was probably mine. Here. Here. Sorry, mine just... Here, you want to trade? There's a clean one. So, up here, we get told this shape is the result of Charlie having multiplied every coordinate by 4. This has already been done. So what we're being asked is if that's what we did, how could Charlie undo that and then go ahead and do that? Go. Like on your paper, I think you guys know what to do. That's why people are raising their hand. How do we undo that? And let's go ahead and do that. How do we undo it? Go ahead and do it.
You can't rhyme with the same words.
I wasn't trying to rhyme.
Oh, okay.
Don't have to do it all the time. They might say it's a crime.
Oh, we have little Mr. Rapper. Anyways, continue.
As long as we don't involve any slime.
Oh.
Then we'll all be fine.
That was so
Ahmad coming in with his chime. I like chiming in. Okay, now we're trying really hard. Ooh, to be on time. Ella, how can we undo multiplying by 4? Divide it by 4. So if you really want to, what you could do first is write down where these points are, like in the current moment, and luckily the bolder lines are kind of the darker ones here. Remember that it's X, Y. Guys, even after we practice this, it's still a trapdoor that people sometimes switch around. Y, like it is X, Y. Always X coming first. Now what's tricky is we have both the points 4, 8 and the point 8, 4. We have both points 4, 8 and 8, 4. -4, +4. Huh, well that's fun. Yeah, again, mathematicians, we think we're clever. The rest of the world just isn't smart enough to know that we are. See, at least Beatrix understood that I'm joking. Now, hold on. Before you actually do this, I want you to make a conjecture of where this new shape is going to end up. So we're going to take the points that we have, and we're going to divide by 4 to dilate this shape down, right? We're going to dilate it smaller instead of dilating it bigger. Make a conjecture in your head, where is it going to land, and then go ahead and do it. We're going to take each point and divide by 4. Where's the new shape going to land?
Can we like name them?
Sure, like A, B, C, D or whatever.
Yeah.
Sure, you can name if you want.
Can we name them actual names?
No.
That's at home. No.
We're up here. Sorry, that's a different problem. 53 is a different problem. Like, so up here. And, okay, so this is the point. I'm going to, like, let the cat out of the bag. Negative 4, 4. When I divide by 4, what's that point turn into? Negative 1, 1, which lands right here. Suspicious. Simon, you already got this done? 4, negative 4, because your helicopter's just distracting me. Ends up at 1, negative 1. Suspicious. 4, 8. What's that become? Ooh, 1, 2. 8, 4.
It equals 2.
2, 1. Why does this look like it does? Why did it land? Can anyone talk to me about just what just happened? Beatrix, you able to talk to me about what just happened?
Like the line that's like kind of the bottom left line, like stayed the same, but then everything else just kind of like went inward.
Okay, so we used a scale factor, if we want to refresh our brains. Our scale factor here to get smaller like this was what?
4. Negative. No. Divided by 4.
Scale factor is always what we are multiplying by. So guys, this is why we're reviewing this. What scale factor gets us shrunken down?
Wait, our scale factor is
One
negative 4.
fourth. You cannot have a negative scale. Now, you can multiply things by negatives, but that's about rotations. Your scale factor has to be positive, somewhere between 0 and infinity. So, the closer you are to 0, you're shrinking down. Closer you are to infinity, you're getting bigger. So we got a scale factor of 1/4, and because this connecting line was through the origin, our new shape goes through the origin also. Any questions on that one? All right, final challenge for today. And guys, this is one of those, like, if we feel good enough after, like, whizzing through this stuff real fast, might be able to just spend some time, like, just working on practice, like, in future days or whatever. All right, I want you to graph these points. -1, -1, -1, 1, 1, 2, and 2, -1. I know I said those way too fast.
No, but it was good for us. Wait, so do we put them on the... Like,
On the bot, sorry, this is 53 now. 53 now.
Perfect color. Do we connect them? Yes. Wait, do we connect them? How do we go?
I mean, connect them at some point. The shape you are making is Alma's shape she made after dilating by 1/3. You're going to undo her dilation by 1/3. So the shape you're making was the result of her shrinking them down. Like Honey, I Shrunk the Kids, right? Honey, I Shrunk the Triangles. Actually, well, this is going to be a quadrilateral. Missed opportunity movie. Daddy, I Dilated the Dogs. Well, like Honey, I Shrunk the Kids. Daddy, I Dilated the Dogs. Alex, what's up?
How is it scientifically possible?
What? Have you never seen Honey, I Shrunk the Kids? You need to go ingest a film.
What is it?
Just watch. But I'm just saying it weird.
Is it mathematically possible to solve how much food would woodchuck chuck and woodchucks chip wood?
There are some really interesting threads out there. Obviously, the internet is full of bad things. But there are some very interesting threads full of nerds discussing problems like that.
I need to find these.
Well, what you need to do is get caught up on your homework. I don't think you should be spending your time thinking about how much wood could a woodchuck chuck, because I want to know how much homework could an Akmon do if an Akmon did his homework. Guys, we're at that really honest point in the year, which is also why August makes me sad again, because I can't be honest with my students, because then they get hurt feelings or think I'm being serious or mean. I mean, I am being serious. I'm not trying to be mean. To undo a dilation of 1/3, what are we going to do? Yeah, we're going to multiply by 3. If you want to write out what you're going to do, you could write out the original points and then write out what they become. And we're going to pick this up tomorrow since it is now time to go to lunch.
Wait, for homework, are we going to be asked to write them out, or are we just going to be asked to do
Well, I don't know. Look at do you have your homework in front of you? I forget exactly what problems are on this.
Okay. Thank you, sir. Sir, I feel like at the start of the year, it's really important to know report, but also it's good to be me at the start of the year, because that shows the kids that you can't just step all over you, you know.
So I kind of disagree. It's
It's
good to be firm. So my aunt, God bless her, she was a great teacher. But my aunt would say, don't let them see you smile until Thanksgiving. And I'm like, I don't want to be that teacher
Yeah, that's kind of
that kids think, is always mean and angry. I love my job.
Well, and kids will not care about their pets, but they'll just write you off as pets.
Yeah, so I like establishing a mutual respect rapport.
I'm not saying be mean, but I'm saying if they step.
But you did say be mean.
Well, I know, which is why I'm correcting myself, guys. Calm down. Well, no. Once you build up a relationship with people,
Bye, guys. Have a great day.
they know that
Thank you. Oh, I had papers.
you know that they
If you're wanting papers back from me, come get them. Otherwise, I'll pass them back tomorrow.